Assalamu alaikum wa rahmatullahi wa barakatuh. Today I'm going to talk about a special case of integration by parts. It is called integration or repeated integration by parts, or it is called how to evaluate an integral by parts several times. We will start with the following example, first to know why it is called repeated and how it is important. Start with this example. If you look at this example here, integration of x squared e to the power x. I need to recall why I should use integration by parts. What does it mean? Integration by parts, it's integration of the product of two functions. They are not related to each other, not function with its derivative like substitution. And integration by parts, from its name parts, we will write this integration, or we will divide this integration into two parts. One we will call it u, and one we will call it dv. How to choose u? We need to remember something called liat. L stands for logarithm. Here I don't have logarithm, so I'll ignore it. I stands for inverse. I don't have inverse function here. A, algebraic. Yes, I have algebraic function here. So algebraic, it is this one. That means this part will be called u. So u here will be x to the power 2. Now this I have t, trigonometric. I don't have trigonometric. E, exponential. Yes, I have exponential. That means the second part or the last part will be exponential. Since a comes before e, so a is u and e is the other part, which is dv. So dv here will be e to the power x dx. So if I want to find now, what I need to find, with u I need to find du, and with dv I need to find v. So with u, which is x squared, and dv e to the power x, with u I need to find du here, which is 2x dx, and dv I need to integrate both sides, and the integration of dv will give me v, and the integration of exponential is itself. Now, applying the integration by parts, which is multiplying u by v, then minus new integration v du. So if I apply this one, I will get u, which is x squared, and v, which is e to the power x that we found here. And also I have a new integral, which is called v du, and v we found it, which is x, e to the power x, and du we know it is 2x dx. So I got a new integration. This new integration is still product of two functions. One is exponential, one is algebraic. So in this case I need to do integration by parts again the second time. This is why we call it integration by parts several times, or repeated integration by parts, because I will repeat again the method of integration by parts for the second time. For that reason, this method, it's a little bit long, so I need to do integration by parts again. Again I have algebraic, which is u, and the remaining will be dv. So u is x. That means du will be 1, or du will be dx, and v, it is integration, which is the exponential itself. And I apply the integration by parts again, but only for this new integration. So I will have uv, this is uv, which is x e to the power x, and I have also v, a new integration, which is v du. A new integration, which is v, which is e to the power x du. So here I got a new integral. I don't need to do integration by parts again, because we know the integration of exponential is itself. So I got the answer. So here we can say integration by parts repeatedly or several times, it takes time. I need to repeat 2 times. What if the power is 3? What if the power is 5? So I need to repeat it 5 times. This is why this method, the normal method of integration by parts, it's useless. or it's difficult to be applicable if I have higher powers. So there is a special method of integration by parts. This is special method. It's called Tabular method. Tabular method, and we call it always a special integration method. And this one works only if I have polynomial multiplied by exponential, and I have polynomial multiplied by trigonometric. Only this method, or only these two cases, we can use integration by parts repeatedly, or tabular method. We will call it tabular or table techniques. We will see how this method is easier than doing the integration by parts more than one time, several times. Why it is important first, if I have exponential with polynomial, we know if I use u as polynomial, so the polynomial will be considered as u, and usually when I repeat the integration by parts, I need to find du, which is the derivative. And we know that the polynomial, after several times of differentiating, it will become 0. So when I differentiate the polynomial several times or several steps, I will get 0. That means this integration will stop there. And integrate the other part to get v. Also, if I have a polynomial with a trigonometric, polynomial will lead to 0, and trigonometric will be repeatedly again. Now, let us take this example to understand. If I want to use the normal integration by parts, I have to repeat the integration by parts 3 times. And we know repeating this wasting time. So we will use a special method which is called tabular method. Tabular method or table techniques. We will see how we deal with this one easier than the normal method of integration by parts. First, we make a table. I will use here u and here dv. And with u, I will go the next step by finding the derivative always till I get 0. Till I get 0. And here I will find the integration several times. And since it is alternative, so the first sign here will be plus, and here will be minus, then plus, then minus, and so on. So this is the main idea of, or the main shape of tabular. So we need to remember the sign, plus, then minus, then plus, then minus, then plus, always. So let's start with u. Clearly, if you remember here, that u is algebraic. And we said algebraic, like this one, or polynomial. So this will be u. I will go forward to find the derivative. So the derivative will be 3x squared. Then the derivative again will be 6x. Then the derivative again will be 6. Then the derivative again, 0. That's it. We finished the derivative 3 times. Now dv, it's exponential itself. And I need to find the integration for this part. So when I do the integration, I will get also exponential. Then I do integral again, exponential, then exponential, then exponential. Now let us see how this method works. After doing the table, or after filling the table, I will multiply this part, which is x to the power 3, by, or diagonally, by the second one in the table. And I take the sign, the first sign, which is a plus. Then I multiply again the second one, which is 3x squared, by the next part on the other column. Then I go again to take the 6x, and I multiply 6x by also the next one. Then finally I take 6 and I multiply it by this one. So we will get what? First, this is the integration. when I first multiply x to the power 3 by e to the power x, so I get x to the power 3 multiplied by e to the power x, and the sign is plus, so I don't need to write it here. The second one, clearly, I will take this minus with this 3x squared and multiply by e to the power x, so it will be 3x squared by e to the power x and minus. Then the third one will be 6x, as you can see here, multiplied by e to the power x and the plus sign. Then 6 again by e to the power x itself, and we don't forget plus c. So this is the idea of tabular method. Let us take another example to this idea. I have here x to the power 3 sine x, and clearly this is polynomial, so this will be u, and here the remaining will be what? dv. So I need to make a table. This is the table, and with this table I will use u, then I find the derivative more than one time, and dv, I'll find the integral more than one time. So the first one, u is x cubed, then 3x squared, then the derivative again 6x, then 6, then 0. And the sign will be sine x, then the integral of sine x, we know it is minus cosine, then the integral of minus cosine here is still the minus as it is here, but the integral of cosine, it is what? It is sine, so the answer will be minus sine. Then again the integral of minus sine, the minus as it is, and the integral of sine, it is minus cosine, so the answer will be minus by minus will be plus cosine. Then I do the integral again, the integral of cosine is sine. And I don't forget this here, the first one plus, and this one minus, then plus, always, then minus, then plus, alternatively. Then I do diagonally, or I multiply diagonally, which is x cubed by minus cosine x. X cubed, look here, by minus cosine x. Then 3x squared by minus sine x. And I have minus here with minus, which will be plus. Then 6x by cosine x. 6x by cosine x. Then 6 by sine x. And I don't forget the plus c. This is the tabular or table technique. Look at this example. Can I do tabular for this one? Think about, I have polynomial, but I have ln. Let us see, we can do or not. Let us make the table. U and dv. U here is ln x, not x cubed. Why? Because of liat. L logarithm. Yes, I have logarithm. Since L is logarithm, so that means this will be u. And the remaining is dv. So if I apply tabular, I will find the derivative of ln. And we know the derivative of ln is 1 over x. And this one, the integration will be x to the power 4 over 4. If I continue, I will never get 0. I will never reach 0. This is why integration by tabular works only with polynomials or x to the power n with trigonometric or with exponential, not with any other function. Thank you very much. See you later.